Have you ever really thought about how a crypto transaction can be completely private, even when it's happening on a public blockchain? It kind of sounds impossible, right? Well, today we're going to follow a single Harpo transfer on its secret journey. We're going to pull back the curtain on the cryptographic magic that keeps your financial data safe. Let's dive in. So, right off the bat, we're faced with this fascinating paradox. I mean, the whole point of a blockchain is that it's this public, transparent ledger that anyone can look at. How in the world can you build real, genuine privacy on top of something that's designed for everyone to see? And that really is the million-dollar question, isn't it? How do you send value from one person to another without telling the whole world who sent it, who received it, or how much it was? It honestly sounds like it can't be done, but the secret sauce is in a really clever mix of data structures and cryptography. Okay, so how do we start to crack this puzzle? It all begins with changing how we think about what money in a crypto wallet actually is. You have to forget that simple account balance you see at your bank. In the world of Harpo, it's all about these things called UTXOs. A UTXO, which stands for unspent transaction output, is the key idea here. And honestly, the best way to wrap your head around it is to think about physical cash in your actual wallet. You don't just have a single balance of $50. You probably have a 20, a couple of 10s, and maybe some 5s. Each of those is its own separate spendable thing. UTXOs are just the digital version of that. And this comparison really makes the difference pop. You know, the traditional account model is just one big number that goes up or down, but the UTXO model, it's totally different. Every time you spend, you're literally handing over specific digital banknotes and getting brand new ones back as change. This might seem like a small detail, but it's the very first and maybe most crucial layer of privacy. All right, so you've decided to spend a few of your digital banknotes. Before the network will even consider your transaction, it has to run a super rigorous cryptographic security check. I like to think of it as a gauntlet with 5 critical verification stages it has to pass through. So this is a gauntlet. Before any transaction gets the okay, it has to prove 5 things. It has to prove it's a real banknote, prove you own it, prove the math adds up, prove you're not trying to spend it twice, and prove it hasn't been locked. Let's break down how it clears each one of these hurdles. First up is the existence proof. See, your UTXOs is stored inside this huge private data structure, a Merkle tree. A zero-knowledge proof lets you tell the network, hey, I promise the banknote I want to spend is in this tree. But, and this is the magic part, you don't have to reveal which banknote it is. Your privacy stays completely intact. Next, you've got to prove you actually own it. You have to show that you have the right to spend this digital cash. And again, with a zero-knowledge proof, you can cryptographically show that you hold the secret key for this UTXO without ever letting the network see the key itself. It's like unlocking a door to prove you have the key without ever showing anyone what the key looks like. Now, check number 3 is a rule that sounds incredibly simple, but it is absolutely critical: mass conservation. The system just makes sure that the value of the digital banknotes you're putting in is exactly equal to the value coming out. That includes what you're paying and any change you're getting back. It's just a basic balancing act to make sure no one is creating money out of thin air. Okay, but if everything's private, what's to stop someone from just spending the same digital banknote over and over again? That's a great question, and the answer is something called a nullifier. When you spend a UTXO, it creates this unique one-time use serial number. And that serial number gets published for everyone to see. Honestly, this concert ticket analogy is perfect. A nullifier is just like that barcode on your ticket. The ticket doesn't say who you are or how much you paid. But once the usher scans it at the gate, it's marked as used. If you try to use it again, no way, it's been nullified. And that brings us right to check number 4, preventing double spending. The Harpo network keeps a public list of every single one of those scanned tickets, or nullifiers. So before your transaction gets the green light, the network does a quick check against that list. If your nullifier's already on there, transaction rejected. It's that simple. And finally, the 5th check is lock verification. You can think of this as a built-in compliance feature. If, for some regulatory reason, a specific UTXO has been flagged and blocked, the cryptography itself will enforce that block. The proof you need to spend it just won't generate, and the transaction is stopped dead in its tracks. So our transaction made it. It passed all 5 checks. It proved it was valid, that you owned it, that the math was right, that it was unique, and that it wasn't locked. The gauntlet is officially complete. So what actually changes on the blockchain now? Well, 3 key things happen. First, that nullifier. The serial number from your spent banknote gets added to that public used ticket list. Second, new UTXOs are created in the private Merkle tree, one for the person you paid and maybe one for you as change. And finally, the transaction gets recorded. The end result is amazing, a system that is totally private for you, the user, but still completely verifiable for the entire network. Now, all this talk about privacy, it naturally leads to a really big question. Does all this cryptographic shielding just create a completely sealed-off black box? I mean, what happens when someone like a regulator needs to see what's going on? Let's just tackle that question head-on. If you need to prove your transaction history, maybe for taxes or some other compliance reason, does this privacy design get in the way? Do you have to choose between total privacy and zero transparency? And the answer is actually a surprisingly elegant no. See, Harpo was built for what's called selective auditability. You, as the user, have the power to reveal your transaction data to a third party, like an auditor. And here's the really clever part. You can use ZK proofs to cryptographically prove that the data you're sharing is the real deal, that it's authentic and hasn't been messed with. It creates a path for compliance that doesn't blow a hole in privacy for everyone else on the network.
And, that really leaves us with a powerful final thought. What we've seen is a system that gives you powerful privacy by default, but also has the tools for verifiable compliance right when you need it. Could this be it? Could this be the breakthrough model that we've been looking for to finally balance that fundamental right to privacy with the realities of regulation in our digital world? That's a huge question to think about. Thanks for joining me.